Okay, so today we're going to eventually get you into tangent and cotangent, but to start with, let's just talk about sine and cosine. So if you were going to graph sine, I hope this is like yawn, super easy, right? Okay, so what are the numbers you'd have on the axis? Well, you know it's got a period of 2 pi, so it ends at 2 pi, right? Please graph that quick and fill in the numbers in between. And also on the y-axis, see if you remember the numbers for that. All right, hopefully you said this was pi, because that's halfway, right? Do the half technique, it works really well. And half of pi is pi over 2. And then you should just ask yourself, what's between a whole pi and 2 pi's? 1.5 pi's, which is known as 3 pi over 2. Good. And then this is 1, and this is -1. Raise your hand if you're confident that you can do that. You're good at that. Okay, good. So what rides on top of that? If I wanted to graph one of those other funky functions, cosecant, yes. And cosecant, why don't you put it right on the same graph? It goes like this. Now you've graphed cosecant, and yes, you need asymptotes running like this, and this, and this. Now why are there asymptotes there? Because if sine ever becomes 0, cosecant is 1 over sine. If cosecant is 1 over sine, if sine ever becomes 0, then it'll be undefined. Well, right there is a spot where sine becomes 0, and therefore it's 1 over 0, which is undefined. That's why here and here and here are all important spots, because they're spots where sine is 0, and therefore cosecant is undefined. All right. Do you get sine and cosecant that goes with it? All right. Now let's talk about cosine. Draw me a separate graph. Cosine starts out high at 1, goes all the way down to -1, then comes back up to 1. It gets all over with at 2 pi. It won't hurt you to get the repetition here to know that this is pi, and this is pi over 2. 3 pi over 2, and then this is 1, this is -1. Good, there's cosine, right? Then what rides on top of cosine? Secant. So secant would be here. I'm going to just do this like this. Why did I only do part of this loop? Because I'd be going past 0, yeah. I don't really want to graph it over in the negatives. Now I could continue this. That'd be all right. Now I got 1 full up and 1 full down. Does that make a full period of secant? Yes, it does. Now could I have done it another way? Yes. Watch, I could go like this. Now I got a whole down and a half of an up and another half of an up, makes a total of 1 up and 1 down, and so that's a full period of secant also. Either way counts. The only way you'd get in trouble is if they asked you to specifically graph it between 0 and 2 pi. Then you'd have to do it the way I just did it there. All right. So let's talk about where sine, cosine, and tangent come from. If you boil it down to x and y and 1, then I'm in the what circle? The unit circle. Good. Then, if I do sine of theta, this being theta, sine would be opposite over hypotenuse, which would be y over 1, which would be y. Remember how sine is what? What's cosine then?
X.
X, yep. Because cosine of theta would be chi adjacent over hypotenuse, x over 1, which is x. And the last would be tangent, which would be y over x. But we're not going to say it's y over x. Stay with me. We're not going to say it's y over x. We're going to say it's sine over cosine. It's pretty much the same thing, right? But the point, if I say sine over cosine, then I'm telling you how we're going to get the tangent graph by taking the sine and the cosine graph and dividing them. How about this? When I'm doing tangent, do you get that when cosine is 0, it's going to be undefined? You get how if this part right here is 0, then I'll have something divided by 0, which is not okay. And so therefore on my tangent graph, do you get I'm going to have dotted lines because there's going to be spots wherever cosine is 0, there'll be dotted lines there. All right. Okay, I think I've gone through enough of the kind of the background stuff other than the stretching part. Let's say I was going to do sine of 2x. Do you remember how we would do that? You'd start by graphing sine, and then you would not even change the graph. You would change the numbering. Remember that? And instead of saying our period used to be 2 pi, now it's 2 pi over b, and what's the b? 2. So we stick a 2 in there, and then this one would have a period of pi. So this graph right here now has to have a period of pi, so the pi goes here, and then you renumber accordingly. Right? You say this must be pi over 2, this must be pi over 4, 1/4, 2/4, this must be 3/4 pi. You get what I did there? All right, I'd like you to do one just like that. I'd like you to graph for me y equals sine of 1/3 pi. No, x, sorry. 1/3 x. And what you're going to start by doing is graph normal sine. And then just renumber it. I want it on highlight. Ah. Let's go of it. There, good. Okay, if I was going to graph this, first thing I'd do is graph sine. Here's sine. Sine goes like this. Then I would say, well, instead of 2 pi where it used to end, now it's going to be, well, I'm going to make a little formula. Period is 2 pi for normal sine over b, which is 1/3. How do I divide by 1/3? Times by 3. 3 times 2 pi makes 6 pi. This should be 6 pi. Raise your hand if you did that right. Okay, good. And if that's 6 pi, this is 3 pi, and this is half of 3 pi, which is 3 pi over 2. And 3 pi over 2, 6 pi over 2, this would be 9 pi over 2. Get that? And then the last one would be 12 pi over 2, which is the same as 6 pi. Okay, here we go. Now what if I threw in an extra 8 in the front? You just have to change one little thing. You're right. 8 here, negative 8 there. Good. Okay. What if I flipped it? Threw in a negative in front. Then I'd have to redraw it, but I'd leave all the labels the same. But I'd just go like that. And I'd erase my black one. Okay? That's if I flipped it, threw a negative in front. All right. So there's a review of the kind of the stuff you're supposed to know so far, and here's what tangent looks like. But this graph's a little bit busy, so I want to give you one that's a little easier to see. But let's just look at tangent for a second and notice that it's the same exact pattern over and over and over and over again. So getting it done between here and here, that is a full period. So its period does not take 2 pi to get a whole picture done. It takes a half a pi here, and a half a pi here makes a total of 1 whole pi. So the period of tangent is pi. It's important to know. And same with cotangent. You get the whole thing done in pi instead of 2 pi. All right, notice that tangent goes up as you go from left to right. It's always increasing. Cotangent's always decreasing. It's always going down. And when it resets after it hits one of these, absolute values, which it never actually hits, once it hits the, not absolute values, what is it called? Asymptotes, thank you. Then it goes over to the next one and starts going down again. So tangent and cotangent are different that way. And also notice tangent goes right through 0, whereas cotangent does not. All right, so you'd think that you just take tangent and you flip it over and you got cotangent, but you don't. All right, so let me give you a nice clean picture of tangent. Here's tangent. Dotted line, dotted line. Dotted lines are at pi over 2 and negative pi over 2, making a total of pi between the dotted lines. And therefore its period is pi. Get that? That's tangent. How about the parent for cotangent? Here's cotangent. Cotangent, you got to go over here and have it go down the whole time. Also gets done at pi, so then this is pi. Now, some of you might be asking, why doesn't it just, why can't you just take the tangent one, which was like this, and then flip it over and have it, go down like that? It has to do with what is cotangent. You know how tangent is sine over cosine? Cotangent is cosine over sine. So what does that mean? I'm going to graph sine on here. Sine goes like this. When, I actually think it's better to just keep going with my picture. Okay, it's off a smidge. I'm going to realign it here. There. Okay, so what happens when the blue line hits right here? Sine has just hit 0. Do you get how if sine is 0, that cotangent will have a problem? Because when sine hits 0, cotangent is undefined, and that's why it creates this little guy. Right through that spot, you have an asymptote. Okay? That's why it's contained. And here's the other spot. Sine hits 0 right here. So it's another spot where there's got to be an asymptote. And if there's got to be an asymptote here and here, where are you going to draw your thing? Well, in between. Okay? So, if I give you this picture right here, which one is it? Tangent. If I give you I know the answer is going to be cotangent, but oh crap, I drew that really bad. Try again. There. What I was going to say is, what is its x-intercept? Yes, because this would have to be pi, and the x-intercept would be right there, which must be at pi over 2. All right, and that is cotangent graph. All right. We covered a lot of stuff really fast, but it does get a little bit more complicated, but not too much. Let me go through a few more thoughts on this. Cotangent and tangent, just as you are made up of a combination of your mom and dad, their genes together made up you, tangent is made up of what? Sine and cosine. All right? And if you wanted to know how tall or how high you were going to get, you'd have to look at your parents, right? To determine that, right? Well, there's actually a pretty complicated formula. It's not that complicated if you really look at it, where you take your father and your mother's height and your father's father, which would be your grandpa on your dad's side, and your grandma on your dad's side, and basically your grandma and grandpa's and your mom and dad, and you add them all up and you divide by 6, and as in you average the heights of your grandmas and grandpas and your parents. If you average all their heights and you times it by 1.08 if you're a guy, as in you're going to be a little higher than the average of your grandparents and your parents. And if you're a girl, you multiply by 0.92. In other words, you're going to be slightly lower than the average height of your grandparents and your parents. You will be within 95% certainty that will be your height. There's a 95% chance that you'll be that. Isn't that cool? So if you really want to know how tall will I get, ask your parents how tall your grandparents were, and get the grandparents' heights, and your parents' heights, add them all up, divide by 6, and again you times by 1.08 or 0.92. this, okay, let me figure out what that was again. I looked this formula up on a reputable website, and I cannot remember what that part is. So I haven't actually calculated this for myself. I'm pretty much stuck, I know, for myself. But I'm kind of curious for my son. He's one of those guys that hasn't grown much since like 9th grade. Whether or not he's going to get any more, or is this all he's going to be, or what. But anyway, I'll have to look that up and see if I can find out what the scoop is on that. Yes?
What about, though, like, grandparents shrink a little bit from their initial height. So
You're absolutely right.
His prime, probably a little taller than he is right now.
You're exactly right, and you should take that number. Grandpa probably knows. Most people, if Grandma and Grandpa are alive, it's going to be really easy. Just ask them how tall they were, and they'll say, yeah, I've shrunk a little bit, but I used to be 5 foot, whatever. Everybody knows how tall they were. And if
also,
Grandpa's gone, you have to ask Mom and Dad, and just they can always give you their best guess.
Also, one thing that's weird, though, is, so if I'm looking at your little key,
Yep.
you said, so let's say your mother's mother,
Yep.
it says in centimeters, but then when you're doing this addition,
No. This is all in inches. You're right that there was 2 formulas, and I took the one in inches. So ignore these centimeters things. You're right. I'm glad you're looking at the details, but I changed it to
I only
inches.
said that because if you look at the 5.5, that unit is in inches, so I was not sure.
Yep, and I changed them all to inches, and I believe that I've got it correct, but I could be off. I'll have to relook it up because you got me on this. I'm not sure what this is. You guys have looked at this much more closer than my other classes, which is good, but
Also, who are those little people? Or, if they're your parents.
they are not my parents. This does look like Bernie Madoff a little bit to me.
I see it a little bit.
Yes?
So then, like, based off that, from over time, like, guys were going to get taller and then girls were going to get shorter?
I think it's more just that when you average these groups, that you're adding in males and females, right? If you just took the average of all the males, then you're probably going to be right at that, right? But you're averaging in males and females. So.
Do you have any, like, uncles, or it doesn't even matter? Is this, like, the best way to figure it? The more people you have, like, wouldn't you say that the more genetic data you have?
I agree that would make sense that the more data you would have, the better it would be. But I
Yeah.
Wouldn't have anything to do with like what you
Yeah.
their genes are going to be the same as
it would. You're right.
But yeah, but if you, okay, so, like,
You'd have to do grandparents' parents, so it'd be like great-grandparents. Yes, I'm sure if we added that in, it'd be better. Can we move on, though? I'm glad that you're into this, but let's move on for now. Napoleon, even with the hat, shorter than Obama. But, surprisingly enough, taller than some of the major leaders of some of our foreign countries. Do you know where Medvedev comes from? Russia. Yep. Sarkozy's France.
the other guys in Italy.
Berlusconi's Italy, yep. And not exactly tall guys. I've seen Sarkozy grab up or stand on the box before when he gives a speech. Thought that was kind of funny. So.
5'11's pretty average.
And Medvedev is just getting replaced with Putin, right?
Yeah.
I think they just had their elections over there, and didn't Putin win?
Oh, I thought you said Russia.
No, he's dead. Putin. All right, moving on. So, I don't think we need to do this one. It is important that you get the idea that you can sketch 2 periods of something. And if you're going to sketch a period of secant, secant's the one that goes with cosine, right? Cosine goes like this. I missed, but that's close enough. And then it would go like on top of it. If I just do this, that's going to become 1 period of secant. Do you get how that's 1 period of secant? If they ask me to do 2 periods of secant, I just need to continue my graph and go farther. And some kids ask, can I go farther this way? Yeah, if you want to do that and then make another one over here, that's fine. And then you'll have to have the rest of that, and then some more over here. But you basically would have to have 2 ups and 2 downs. Or if you wanna, you can just go like this and go a little bit farther over here, and now I've got 2 ups and 2 downs. See what I mean? So I went from here to there. Anyway, the point is that you can do your 2 periods any way you want to. But 1 period is going to be 1 up and 1 down. 2 periods will have to be 2 ups and 2 downs. And yes, they can go in half increments. Like a half plus a half makes a whole up. All right, moving on. Remember, tangent is made up of sine over cosine. So anytime cosine is 0, that's where you're going to have those dotted lines. And cotangent is made up of cosine over sine. So cotangent whenever this is 0, whenever sine is 0. So here's where it's 0, doink, doink, doink. Those are spots where you'll have to have dotted lines then when you're making cotangent. Cotangent again always falls, so cotangent would be something like that. All right, moving on. What if I had to graph this? Cotangent of 2x. First thing, you graph cotangent. Everybody graph cotangent. Just graph cotangent like normal. Ugh, that's terrible. And now, I just changed the numbers. But here's the important part. It's not 2 pi over b anymore. Why not? Because the normal period is actually pi now, so it should be pi over b. And we know what b is. B is 2, so it should be pi over 2. And kids get all proud of themselves that, oh, it's pi over 2. I know that's right, so I'm going to put a pi over 2. And you just got to be careful that the total distance from here to here is pi over 2, right? So that is pi over 2 in this case. But on the tangent graph, it'll be the same thing. I'll show you that is for tangent in a second. On the tangent graph, you'd have it like this, and let's say you figured out the period's pi over 2. You can't just put the pi over 2 right here, could you? Because you'd have to have this distance plus this distance make a total of pi over 2. All right, so all I'm saying is in this case, we're going to luck out. But you got to be careful with that. Don't just grab this answer and slap it in automatically. But if this is right, which it is, then this would be pi over what? And there's my final answer for that one. Yes, ma'am. Is cotangent always through this spot? Yes. All right, moving on. Let's say I asked you to graph tangent of 1/2 x. First of all, graph the parent. Graph tangent. If you know what tangent looks like, graph it. Yep. If you don't know these parents, you won't have a chance. So tangent, parent. Tangent's the one that goes through the origin. Tangent's always going up. If you got a tan, things are looking up. That's a good way of thinking. All right. And a cotangent, I don't know, it's like co is like sort of like, there you go. Co is sort of like cold, and therefore you don't get a tan where it's cold. Now, of course, if you're skiing, you can, so that kind of breaks down. Anyway, then the normal period is pi over, you're right, pi over b. The b in this case is 1/2, so we go pi over 1/2. What's pi divided by 1/2? It's the same as pi times by 2. So you get this is 2 pi, and this is the one I was warning you. If you just go slap 2 pi right here, you're wrong. This is not 2 pi. The total from here to here is 2 pi, and therefore, what's that spot right there? Pi to negative pi. It's an easy mistake to make. All right. One other thought, do them in the right order. That one of the things on the test is the type of question where we ask you what order should this be done in. My advice is always start on the inside, because most major big math problems you do that. And on the inside here, I have 2 choices. Oh wait, we got to know what these are called too. Do you remember that this is called something starts with an A? Amplitude. Do you remember that this thing is about shifting it? It's called a something shift. Phase shift. How about this thing that's moving which way? The whole thing goes up or down, and then this last thing is either horizontal what? Horizontal stretch or shrink. Okay, in this case it's a 2, so that means it's not going to get twice as wide, because stuff in there is counterintuitive, so it's going to get half as wide. So that would be a shrinkage. All right, so what order would we do it in? Normally you do multiply before you do subtract, but we're on the inside, so you do it in the opposite of normal order. So this would be first, this would be second. Then on the outside, this is normally first, so it does go first. Third, and this will be last. That's the right order to do it in. Yes?
I always forget, is that just the way you want us to do it, or is there like actually like a correct order?
It is a correct order, and it is the way I want you to do it. But is there another correct order? Yes. If you wanted to do another correct order, you could start on the outside and do those in the normal order. This could be first, this could be second, because remember, it still follows the rule that it has to be in the opposite of normal on the inside and in the normal on the outside. So I could start there and do that, and then go to the inside and do opposite order. Normally I do this first, so I don't. I do that, and this will be third, and this will be last. That is another order. That would also work. I wish there was only one right answer, but there's actually 2 ways you can do it. But don't let yourself think that this means you can start it or you can do it any way you want to. You either have to go on the outside, do all of them, and then go to the inside in the opposite, or start on the inside, do it in the opposite order. That's what I recommend. And then go to the outside and do it in normal order. Yes? You got me on the attendance. And I do have time. All right. It was nice of you to be polite, but that's no. You got to get me when you can get me. If it's 12:02, you can get me. So you got me. All right. Make sure. Yep. And that is it. I've covered everything you need to know.